This is experiment 5, determining the coefficient of friction. Static friction is the point where an object starts moving when a force is acting on it. To find the value of static friction, you need to use the value on the spring and the normal force of the object.
So after a series of experiments, we finally came up with a list of data. To start off, when the mass is 0.5 kilogram and on cork, the static friction is 1.5 Newton, while the kinematic friction is 0.85 Newton. When the mass is 0.25 kilogram on the same surface, the static friction and kinematic friction decrease to 1 Newton and 0.5 Newton respectively. This shows that mass has a correlation with static friction and kinematic friction. So secondly, when the mass is 0.5 kilogram, the static friction is 1.25 Newton, while the kinematic friction is 1.05 Newton. And when the mass is 0.25 kilogram on the same surface, the static friction and kinematic friction decrease to 0.65 Newton and 0.55 Newton. We did the same on wood and got static friction 1.5 Newton, kinematic friction 1.25 Newton for the 0.5 kilogram mass, and static friction 1 Newton, kinematic friction 0.75 Newton for the 0.25 kilogram mass. Also, when we use the angle of repulse method to determine the coefficient of static friction, which means we use an inclined plane and find the inclined angle in which the object just began to decline, in order to find the mule, which is the tan of that inclined angle. And this is our data after a series of experiments.
This is one of our experiments for static friction. First, you need to lay out your variables. Our mass is 0.5 kilograms, and our force of friction, also located on the spring, is 1.5 newtons. We're trying to solve for mu. First, you need to lay out the equation. Then you plug in the numbers. Of course, we need to use the calculator. After hardcore calculation, the answer is 0.31.
And we calculate the coefficient of friction of each weight on each surface. We found out that we had an error, since the coefficient of friction has to be the same on one surface despite the mass. For example, we got 0.29 for 0.5 kilogram mass on cork while using the angle of repulse method, but prior to this we got 0.31 using the spring method. This indicates that during one of the two processes there was an error.